Hello, I'm Sean Connolly, and this is Railway Conversations with Doc Frank.
Hello and welcome back to the show. My guest today is Sean Connolly, and today's episode is about the second part of a conversation that we had recently. We will be talking about the prospects of high-speed rail in Australia, and in today's episode, particularly about the connection between top speed, design speed of the high-speed rail line and the cost for building it, because that's obviously very important for getting a business case right that is viable and makes it worthwhile to spend taxpayers' money on that. Please enjoy this episode, and if you have missed the first part, make sure you watch that one as well. Enjoy. This podcast is not sponsored by third parties, which means uninterrupted listening to the episodes for you, and I hope you appreciate and enjoy that. If you want to support the show to keep it going, there are two ways you can do it. One is the typical request for podcast: subscribe and share with your friends. The other one is specific to the show and myself. I host a training portal with arguably the world's most comprehensive course offer on digital signaling technologies and everything to do with high capacity. Some of my trainings are one of a kind, which means unique in the world. For example, the high capacity signaling blueprint, the high capacity railway mindset training, or most recently, my course about digital signaling interoperability. All of those courses are online, so you can watch the lessons at times convenient for you and as often as you like. And there is an industry-leading Q&A support where I will answer your questions not just during your training, but at least for further 12 months after you completed your course. What you can do that would be really nice is checking out this training portal, which you find at docfranktraining.podia.com. That is docfranktraining.podia.com. And if you find that you or a coworker of you can benefit from any of those courses, I would be very happy to see you growing your knowledge, understanding, and confidence through any of my trainings. Thank you. But now, please do enjoy this episode. Let's talk about speeds for a moment, because that's obviously, and you just mentioned it again, that if your speed is higher than absolutely necessary, let's just put it this way, the cost for building the whole thing may go up to a point where it's not really affordable anymore. And we've just recently covered High Speed 2, the rail project, the High Speed Rail project in the UK, in this podcast here, where it looks like we kind of have a case like that. But I don't want to go back to high-speed rail, I just want to stay here. What you said you've done in the report is a simulation of journey times. And in the report, you have also scrutinized some aspects of the last high-speed report here in Australia, which was done in 2013 by a large technology consultancy. So one of the main criticisms of those of the 2013 study, and you mentioned this in your report, is that the journey times were or appeared unreasonably low, which means that the average journey speed needs to be, well, basically world class, the best of the best, faster than anywhere else. And it's not like it's not like Australia couldn't do that Australians are, I don't know, technically too far behind or anything like that. The problem with these things is that you basically with very short journey times, you squeeze yourself in the corner, requiring extremely high top speeds in order to achieve extremely high average speeds, and that from the get-go drives the cost up.
Of the infrastructure, you need to have the infrastructure. You need a route much straighter, much flatter, which needs more tunnels, more viaducts, which are 3.5 to 4 times more expensive, more more electrical substations spaced more closely together. The cost just goes exponential, and it's exactly what we've seen in England. The cost has increased exponentially to meet a very high design speed that is not necessary. Like I say, I've done some simulation with the caveat that I don't have a route alignment or a track alignment. So that was an interesting guess. So it's all subject to the final route alignment or track alignment that I'll be running over, and where and how they actually build tunnels and things like that, and keep the a nice straight flat track alignment for me to run at that speed. Generally, over the course of these nearly 100 operational HSRs that I've studied, they generally achieve an average speed over their full journey of about 2/3 to 3/4 of their design speed. Yeah. I've had a look at the topology and the terrain. Obviously, we know the terrain between Sydney through the Central Coast and Newcastle's and very, very, very challenging. And you're not going to get much speeds over a very long stretch of much over a couple of 200 kilometres an hour on that route. So, but even so, I still reckon we can do that with 2 stops and dwell times of 56 minutes. Yeah, there'll be a lot of tunnels and a lot of viaducts. However, if we look at the terrain between Melbourne through Shepparton, Albury, Wagga Wagga, and on the way into Canberra, that is largely the outback, the interior of Australia. It's flat. We can build very straight, flat track on ballast, on surface, for just about that whole route, if you like, from Melbourne to just before we get into Canberra. So I do believe that, it's quite possible that we could average speeds of around about 270 kilometres an hour over that part of the route between Sydney and just before Canberra, because it's the outback. It's flat. It's straight and flat, and we can build a nice straight, flat track and route alignment that will support quite high speeds, certainly on that part of the section. So, I take that into account, and I come up with that. I believe that we can do Sydney to Melbourne. The calculations came out at 3 hours 7 minutes, which is which would be an excellent journey time.
It would be, but at the same time, when I read this, especially the journey time table that you came up with as results of your simulation, I thought that would be a main point of potential criticism. We've seen it in the 2030 study. The journey times there, you simply quoted them unachievable. So and this certainly tarnishes the credibility of the entire study, of the entire report, because you immediately ask yourself, well, what else in there is unachievable, unrealistic, whatever. So I really think
the original
those journey
of the original 2013 report. Yeah.
Yes. Yeah. So I think with those journey times back in 2013, if anything, they've shot themselves in the foot. Mm-hmm. Now, what my concern is, and my sneaky suspicion here, that you may have done something similar, because your journey time you just quoted at Melbourne, Sydney of 3 hours and 7 minutes. It's not that much more than the unachievable 245 or so that they had in the 2013 study. So,
it is because I'm certainly not suggesting that an average overall journey time, an average overall journey speed of over 300 kilometers an hour, because that doesn't happen anywhere in the world, not even in China.
Exactly. Yeah.
been realistic. I did do a couple of different simulations. One for a conservative option, which is the 3 hours 7 minutes. But I also did, as a part of that exercise, I ran a scenario which I called the optimistic scenario, which would be even a little bit quicker. So it's validated, it's robust, without having a route or a track alignment. It was the best I could do at the time. But I definitely think it's achievable, and it has been analysed and it has been validated. Along the lines of for comparisons, Spanish or French or European infrastructure or routes that might be comparable. I think that, as I mentioned, that the topology or the terrain between Melbourne and just before Canberra would certainly support long stretches at well over 300 kilometres an hour to come back to an average speed over the whole journey of somewhere in the region of 270 kilometres an hour, which would give you your 3 hours 7 minutes. Yeah. So it might be 3 hours 10 minutes. It might be 3 hours 5 minutes. It might be 3 hours 20 minutes. But it'll be in that general region, certainly, because the topology will support the long, straight, flat stretches of track that would be necessary to maintain for long periods of time those high speeds. Yeah.
I think what would be very useful to have, and I'm aware that there's a lot of work required to get there, maybe more than it's reasonable, but maybe not. I mean, you have established, and everybody else I spoke to on that high-speed subject confirmed that the top speed and the cost of building the infrastructure are very closely related and often in an exponential way, or in a non-linear way. Let's just say. So if you reduce the top speed by 10%, your cost will not come down by 10%. They may come down by 30%, or maybe even more.
Or vice versa. So, to increase your design speed by 10 kilometers an hour might blow your costs up by 50%. Yeah.
Yes. So we have a relationship, one between top speed and cost to build the railway, and then we have a relation on the other side between the top speed and the average speed, which then at the end translates into the journey time. So I think what would be a good thing to have, regardless on how onerous it is, to have some data points of assumed top speeds with related cost and related journey times, and have this for, say, I don't know, 3 different top speeds. So, shall we say 350, because that's the fastest that any commercial high-speed railway has at the moment in the world. I don't think going faster than that would be
380 design speed in China. Yeah.
Yeah. Okay. I'm not really sure we would want to get there in Australia.
No,
so if we go, I mean, one of your recommendations is also to go for international standards. So, for example, if we take the European high-speed standard as an orientation, we are much more likely to settle at around 350 top speed rather than 380. So
330. You could do it at 330. Yeah. 330 design speed.
That's the point, basically, to come up with say 3 data points for different top speeds where you have significant differences in expected cost, and then translates this into journey times, and then you can start doing your sensitivity analysis, what we talked about in the last episode, where you say, okay, well, at a lower top speed, which is much more attractive regarding lower cost, the journey time would go up by 20 minutes. How many of my expected passengers would tolerate a journey time which is 20 minutes longer? Yeah.
And that,
so do I still have a business case, or does my
exactly.
projected patronage drop so much that it stops making sense altogether? Right.
Yeah, and that's sort of where I was coming from. Obviously, I miss the cost of the infrastructure, but I did plot, if you like, a number of data points for various design speeds and top speeds, which translated into journey times, and that's where I mentioned the optimistic scenario and the realistic or conservative scenario. So the third side of that triangle, if you like, is then to cost that out.
Yeah. Because I think this is really one of the most important tasks, to analyze whether you've got a viable business case or not. I think we've seen the example, we mentioned it before, High Speed 2, where for whatever reasons, nobody seems to know anymore, a journey time was committed to, which requires a top speed of 350 kilometers per hour with a very, very high average speed. As a result of that, the cost has been driven up so far that in your study, in your database, High Speed 2 was called out as the most expensive high-speed rail line in the world by a large margin.
Over 300 million euros per kilometer and rising.
Yes. So it's not just the most expensive, it's the most expensive by a long way, by a long margin. So that's definitely a situation which you don't want to have repeated in Australia. So I think in Australia it's critical that you look at it almost as a design to cost, where you say, okay, well,
exactly,
the cost cannot be more or must not be more than this much. Realistically, this will only allow us a top speed of, let's just say 300, just to throw a number which is clearly lower than 350. Let's just say 300, which would then translate into a journey speed, an average speed of blah, 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 and journey times of that much. And then basically investigate whether for those longer journey times, I still think I have a viable case. I still think I can attract enough passengers and have an attractive alternative to air travel and things like this.
Well, again,
because
comparing
the cost will go up. The cost will go up anyway. And I previously, in previous discussions, High Speed, I mentioned Inland Rail as an example, which started off with a budget of $10 billion. We are now at 31.5, and this is still not the end of the line. We did an audit, audit was done on Inland Rail, where the result was the latest estimate is 31.5, which is more than 3 times the original budget. However, the auditor, don't trust this estimate, so it could still go further up.
That's strange. I mean, one of my qualifications is also as a project manager and also as an accountant. So, if we want to talk about HS2, if we want to talk about Inland Rail, I mean, yes, some things happen, and you've got risks that come or that materialize or don't materialize. But I still can't see how any decent project manager or cost manager triples the value of their project. It just doesn't make sense to me. I know it happens. I've seen it happen. But it doesn't make sense to me. So that, if I'm the project manager of this project and is starting to creep up 5% over, 10% over, 15% over, I start to take action. I don't let it get to 20% over, or I cap it off at 20% over. There's all sorts of reasons, and it's been analysed to death. But I mean, with half the project manager hat on and half the accountant's hat on, I can't understand how projects are allowed to exceed original estimates by a factor of 3.
What certainly would make me very nervous is if the high-speed rail network was planned in a similar way that Inland Rail was planned, as being the last large federal infrastructure project for rail. And I don't necessarily want to talk about high-speed 2 all the time. I don't necessarily want to talk about inland rail all the time, with the exception is that none of those things should be repeated for high-speed in Australia. So the lessons need to be learned, and not just face value. Yeah, we looked at it, and what happened there is basically unprecedented, can't happen anywhere else. Well, this is rubbish, right?
That's right. There are risk models that you need to do minutely. Then there is something that, as a mathematician or as a statistician, I understand about P50 estimates. Yeah, and I talk about P50 estimates. P50 estimates are open to misuse, shall we say? Yeah. So if you're not very careful, I didn't put a lot of stock in a P50 estimate, but the government loves P50 estimates. Yeah, so governments do. There are a number of ways to cost projects. Some will take more time, some will take less time. I'd be more in favour of taking more time to do an accurate bottom-up costing of the project than a rubbery risk model that you then run a P50 estimate over to get the median on a very small set of data points that is open to misuse. Let's just leave it at that. Open to misuse. Yeah, I'm not a huge fan of P10, P50, P90 to come up with a best case, worst case, middle case sort of thing. It's stats. It's mathematical theory. Well, yeah.
The thing is that even with a P90 estimate, what it basically says is that there's a likelihood of 90% that the project will come in at the estimated
will not exceed a P90 estimate. Yeah.
Exactly. However, there is still the last 10% risk that this will be overrun.
Even before that, if in order to come up with that P90 estimate, you've made a number of assumptions. Your P90 estimate is theory. It's theoretical. It's not. It's not something tangible that I can say. Well, concrete's going to cost me 43 billion, or steel's going to cost me 32 billion. Trains are going to cost me another 400 million. It's playing with numbers, and I'm a mathematician. I love numbers, but it needs to be the maths needs to be applied correctly.
The cost of this thing. I mean, I'm a railway person. I've worked in the railway industry for more than 30 years. I'm definitely a fan of railways. I'm from Germany. I was a very frequent user of high-speed rail. So anybody saying, "Oh, Frank is against high-speed rail," didn't really understand at all what I was saying for months and months and months. So, but I'm all for high-speed rail if it makes sense and where it makes sense,
applied correctly,
and where it can be afforded. So I think that high-speed rail done right, as you quoted in your report, would be a sensible thing for Australia? Yes, absolutely. At all cost? No. Because then I look at it from a taxpayer's perspective. So the only figure that you mentioned in this conversation here was this $114 billion.
The original.
The previous 2013 study, which now needs to be translated into 2024 figures or whenever the project's going to start. I already heard a number of $200 billion. I'm not quite sure where that came from, and if
you apply the construction index, it comes up to about the construction index over the course of the 11 years between 2013 and 2024, which is something that I investigated and did and got the right index from the Australian Bureau of Statistics. It comes up to about 150 billion in 2024 terms. The HICCC or PPC or something like that is the correct construction index to use for the increase in construction, heavy civils and rail infrastructure construction cost increase over the course of the last 11 years. Yeah. So let's say for the sake of the example that it's somewhere around about 150 billion now, in 2024 dollars.
Well, I couldn't really find a source where the 200 billion come from, but again, people that know more about high-speed rail than I have come up with that figure. So I don't think it was plucked out of thin air. And on top of that, there is the fear that if we get a similar cost overrun for this high-speed one, as we have seen recently with the last big federal infrastructure project here in Australia, which is inland rail, like a factor of 3, let's just say, okay, well, a factor of 3 maybe is a bit extreme, but a factor of 2...
A factor of 1.5 kills it, yeah.
Yeah, exactly. So where is the point where you say, well, if this could happen, it's just unaffordable. It just is. Yeah.
Well, we're also don't forget we're also assuming that the 114 billion was reasonably accurate as well. And we've just mentioned a couple of things, and I also mentioned a couple of things in the report where 114 billion might not have been that accurate in the first place. And I think for example, if you had given it to a competent costs manager, I think it could have been delivered for a lot less than 114 for a number of the reasons that I detail in the report. Yeah.
Okay.
Yeah. So we're taking the numbers that are stated and published, but I also say that I think 114 was probably a bit excessive in the first place. 114 jumps up to about 150, but if they could have done it for let's say 80, 85, 90 in the first place, it jumps up to about 130, 135. Still an enormous number. But we need to. It needs to come in at that 130 or 135 or whatever the final number is. We can't be saying, well, yes, we approve and we fund it at 130, and then a year later it's suddenly 170. That can't happen.
I'm not sure how to get a handle on that, but the whole cost issue makes me extremely nervous to the point where I say in the current circumstances, unless it's there are no guarantees in life, but unless things are done significantly different and significantly better than recently, this thing is not gonna fly. This
I'm not a fan. Well, like I say, as a railway man, as an accountant, as a project manager, I'm not a fan of coming up with a magic number and then a year later it being 50% higher. That just doesn't work for me either. It needs to be beaten down. Sure, some things happen. You include a contingency plus or minus 10% or whatever the relevant percentage is, and that's it. You need to come in under that number.
Yeah, which comes down to project delivery, to cost from that point of view, but it also. There's. I've been trying to get Professor Fleifberg on the podcast, but I'm probably too small of a fish, and he has obviously done a lot of study on large infrastructure projects in general, not just rail, but across. Professor Fleifberg from the Oxford University in England, I believe. Mm-hmm. So he's written a book on major projects, and I will have a discussion on that in a future podcast episode. Maybe not with him, but with somebody else. Anyway, so one of the things that he said, a lot of the things that he said or wrote to me made a lot of sense and really reflected what I've seen often in practice. And one of those things is that if a project is politically desired, shall we say, that the cost estimate, the initial budget estimate, may actually not be that realistic, because if it was realistic, the project wouldn't get off the ground in the first place.
Optimism bias, it's called. Optimism bias.
Yeah, that's one of the aspects, but the other aspect is also an almost deliberate cutting of corners in order to get to an tolerable cost estimate for the project. Basically to get it off the ground. And later on, if it costs more, then okay, well, it costs more. So from that perspective, I actually quite like the current approach to start with a small part of the high-speed network, which will be Sydney to Newcastle.
No, that's a fair strategy, a fair approach.
Hopefully will make sense in itself from a patronage viewpoint, so that later on one could say, okay, well, if it turns out that the larger high-speed network really turns out to be unaffordable, at least we have a fast rail connection between Sydney and Newcastle, which in itself already makes sense and adds value to the Australian economy, to the population, at least in this area. And
given that Sydney to Newcastle will be the most expensive to build per kilometre out of all of the sections.
Yes, but as an exercise to deliver a project to the estimated cost, it will be as valid, if not more valid, than anything else. Yeah, and if they basically realize that Sydney Newcastle, the cost will completely blow out, and that gives them an indication what's going to happen at the larger scale, even for the entire high-speed network, they may still decide to pull the plug and have at least a high-speed connection between Sydney and Newcastle. What I also wanted to discuss with you, Sean, but I think given the time, we'll probably leave this to another episode in the future. In your report, you were mentioning 9 guiding principles and success drivers for high-speed rail. And I mean, going into this, to do it justice probably takes a bit more time. So that will probably be a separate episode in itself. One final question that I had in mind earlier. Do you do anything to try to get your report in front of the really relevant people? I'm thinking the likes of the High-Speed Rail Authority. I'm thinking about the High-Speed Rail Association in Australia, whose director, Joe Langley, I recently had on the podcast. Have you done anything in that regard?
I'm quite happy for anybody to repost it or send it along or whatever else. I'm certainly keen for it to be disseminated as widely as possible and for as many people as possible to see it. And if that raises some questions or people want to challenge me on any of those things, well, so be it. All good and well. Yeah.
Thanks again for your time, and
thank you.
We speak soon about the guiding principles and success drivers.
We'll speak again shortly. Thanks, Frank. Cheers, then. Bye-bye.
Bye.
Hi, this is Doc Frank again. I need to tell you about my brand new online ETCS training. It's the online version of the well-proven ETCS Kickstarter live training that has helped more than 200 railway professionals in Australia and New Zealand, regardless of their prior knowledge of signaling. So that really means you can learn the fundamentals of the European train control system, even if you didn't have any signaling knowledge before the training. How good is that? There's an online study group for networking during the training, and I also provide an industry-leading support of questions and answers, not just during your training, but also for a guaranteed minimum of 12 months after the training. Sign up now at docfranktraining.podia.com/ETCS. That's docfranktraining.podia.com/ETCS.
Hi, it's Doc Frank again. I hope you liked today's episode. I like to keep it as simple as possible, so I only have one single request for you. If you like this podcast, please tell your friends and colleagues about it. That's all I want, because that's a service that I'm providing to the industry. And I would like as many people as possible to listen to this podcast and learn something from it. So please share. And until next time, keep it simple and bye for now. Thank you for listening.